Today we're going to take this Prusa MK2S to a 2.5. Hello everyone, Chris here. I hope you're all well, and yes, today we will be upgrading my Prusa MK2S that I purchased back in March 2017 to a 2.5. And the 2.5 upgrade has been around a while, but I was hesitant to do it up until now on either one of my Mark IIs because they already perform so well, I didn't want to mess up a good thing. And a lot of you are probably saying, why are we doing this now in 2021 when the Mark III has been out for so long? Well, back in late 2020, Prusa did announce they would no longer offer the 2.5 upgrade kit. You can read this blog post from back in November, but they did state they would no longer be selling these kits, but they do offer a lot of information on this upgrade process if you'd still like to do one. So there's nothing saying you can't self-source all the parts for this upgrade. I did, however, buy a couple of the kits from Prusa in late 2020 just to upgrade both of my machines while they were still available. But I thought it'd be interesting to walk through all the steps, how to get the upgrade completed, all the parts that's going to be involved, and the advantages that some of these upgrades might give you. They do offer a removable steel sheet for your bed, dual drive gears for your filament, and a filament runout sensor. So that's what we're going to do today. And this might also be helpful for people with Prusa Mark II clone printers to give you an idea of what you might want to upgrade on those. I have a couple of those myself. So let's get into it, check out all the parts, and get this upgrade completed. So let's start with all the printed parts you're going to need. Now you will need to print out all these parts before you take your printer apart because they are not included in the kit. But we do get an upgraded board cover case. This is much improved from the original one. You get a couple of wire clamps to help with management and the hinges. You have a piece for your end stop. So this echoes the Mark III. The Mark III has sensorless homing, and this style of extruder won't actually hit that end stop. So this is to get you just a little bit further so you can still use your switch. We have a piece for some wire management. We have an upgraded heated bed wire cover. We have a part fan duct as well as the part fan holder. This angles it out a bit to give you just a little bit better airflow. We'll talk more about that in a second. This is PETG, I printed it out. You have the filament sensor housing items, the arm and all the parts that you need for that. And then you have all the new extruder pieces. This is your new X carriage, the back plate for that carriage, the main body for the extruder. This is the part that goes on the extruder motor. These clamp together with this part to hold the hot end, the front cover for that housing, and then the idler housing. Now all these parts are really close to what you're going to find on a Mark III, and this also would enable you to use the MMU2 because it does give you the dual drive gears and that filament sensor. Now when you're selecting which parts to print, I will leave a link to these in the description, make sure you're going from the right model to the model that you want. We are going to the MK2.5S, that is the newest, and my printer is a MK2S, so these are the parts that we're using in this video. But there's an upgrade path for all of the printers, no matter if you're going from just a Mark II or you're going all the way to an MMU2S, just make sure you pick the right parts list. You also get a 300-gram spool of PETG black. It's great filament just to print out your parts. So just note that that's included in there. You don't have to print them ahead of time. But of course that's only if you get the kit. If you just have one setting around, there will be filament inside there. But you don't even need this much filament. This is more than enough to get all these parts done. And here's what all the parts look like from the kit. Let's just get some of these out of the way first. This is a Mark 52 bed with a removable steel sheet. When you bought the kit, you could either select powder coated or smooth PEI. The biggest reason why this one is different is because this is a 12 volt bed. The Mark III is a 24, so this will work with your Mark II power supply. You also get the wires to hook that up. You also get some sleeving for your wire management. You will have to self-source your own gummy bears, sorry to say. So here's a closer look at all the hardware. We'll start with the Pinda probe. Now this is a Super Pinda. This is the newest version. A lot of these kits would come with a Pinda 2. That's the one with the thermistor wire, and you do get an adapter for that. You could use that on your Mini Rambo. There are firmwares to support both, but if you can, get a hold of the Super Pinda. They're a lot higher quality sensor. And then we have hardware bags for both the extruder and just the regular 2.5 upgrade. This has a couple of extra things in it, like these U-bolts that already came with the MK2S. So if you just have a regular 2, you'll get all the upgrade options there. I'll call these out as we use them. magnets needed for that filament sensor, the filament sensor wire, your Bondtech gears to make it dual drive, your IR sensor, a Noctua fan, that'll make it a lot quieter, another adapter to use that fan, some PTFE2s we'll probably use in the install, the extruder body, some zip ties, and then we're back to this part fan. They did include a part fan inside the kit. That's the only printed part there was, because I'm guessing this is probably ABS, just to get a little bit higher temp rating. Now, I've used these with PETG with no problems, but it's probably a smarter idea to use ABS, or even polycarbonate if you have the means to print it. Just note that when you're installing one of these. Hope these aren't like really old ones or something. And before we get started, remember Prusa always has great documentation, including this upgrade. I'll leave a link to this, but all the info is out there, and there's great community pages on this upgrade as well, if you have to self-source. Definitely check it out before you get started. First thing I'm going to do is power up and preheat. Make sure I don't have any filament in the machine. When we're up to temp, I'm just going to go to unload. Trust me, getting the filament out of these extruders before you try to rebuild them is way easier than doing it after. And then we can let it cool down and power off. So let's tackle the wires first, then we'll jump to the bed. We're going to open up our electronics box. I'm going to clip this zip tie. Now, I do have a textile sleeve on this one. I replaced it a while back. Usually you'll have spiral wrap on the older machines. We'll just pull those wires to the side of the case, and we'll disconnect the thermistor and the heated bed. The heated bed thermistor is the one with the green tag on it. It has an H right there. And the power wires are down here. The one with the braided style cable, that's your heater cartridge for your hot end. The one next to it, that's your heated bed. So you can just unplug that one. Now we can pull those through, just so they're loose, and we can remove them. Now we can turn the printer on its side, and we'll move the two screws on either side of the belt holder. It's hard to see with the belt in place here, but you probably don't even need to remove the belt. You can use a ball-ended Allen wrench, get in there and remove them, and the belt will come off without having to take the belt all the way off. So that part is loose. And on the Mark II, there were only 4 bed screws, and they came in from underneath, so 1 on each corner. So we'll go ahead and take those off. And there's nothing wrong with these Mark 42 beds. You could use it on a different printer build, but it is really nice to have that removable sheet. And with all 4 of those loose and that belt, we should be able to just take the whole thing off. Now we're going to move to disassembling the extruder. We're going to take these wires off. We are going to replace this with textile sleeve. It's just a little easier to use than spiral wrap, but we'll cut those zip ties. Same on the controller box side. There's a zip tie over here. And then we can unplug our hot end and extruder body cables from the board, just like we did on the bed. We'll take off the heater cartridge wires. You can just unplug it. The extruder motor is the last motor here on the bottom, down here. It does have an E on it. All the Prusa stuff is well labeled. There's that one. Then the hot end thermistor. It's 2 over from that heat bed thermistor. It usually has a yellow and green stripe on it. It's that one right there. And we need to pull off the current pin to probe. It's right up here, the blue, brown, and black wires up here in the end stop. That one, and then 2 fans, the hot end fan and the part cooling. They're right underneath the thermistors. There's one here, and then a blue one right next to it, right there. Now we can snake all these out of the case and get them loose so it's easier to deal with. Back to removing the extruder body, we're going to cut this zip tie right here. That's what holds the wire loom up on the bottom of the housing. And we're going to remove these 3 screws. This one here, and these 2 down here. And just with those 3, that's going to make that extruder body pretty loose. Then we're going to remove the X belt. You just pull it straight out. We are going to use the same belt to put it back on. And we're going to cut the zip ties that hold the bearings to the carriage. 2 up top and 1 down below. And the whole assembly should be free. We can take off the spiral wrap. We're not going to reuse this. And if you separate the wires, the whole thing will just come right out the front. Now we'll remove both the fans. This one here for the hot end. With those 4 screws, that just comes off. Then we'll take off the screw that holds the fan duct. And the 2 for the part fan. Part fan's off. We can take the screw loose for the pin to probe. There are some square nuts in some of these parts, so don't lose them. Square nuts are always handy to have extras. As well as having extra pin to probes around. This is the version 1, but it's also the same one they use for the fender on your MMU2 if you have one. Then we can go ahead and fully separate the back plate here and remove these 2 screws to separate the extruder body. These are the last ones that hold the extruder motor on. And the extruder motor is off. And we can take these 2 loose that hold the idler on. Again, another handy part to have extra if you have Prusa printers are these springs. They're the same spring they use on both extruders. And the idler's off. And now we can take these 2 screws off and remove the idler cover. This is what holds the hot end in. And those are apart, and the hot end should just pop out. Now is a great time to inspect all of your wires, thermistors, heaters, make sure everything is still in working order, or replace it. Hot end is out, and if you're like me, like I said before, make sure you scavenge all of the hardware so you can have it for spares for later. All the hardware is included in the kit, but as we go back together, I'll shout out the different parts that you're going to need. Now we'll move on to installing the new extruder. This is our new X carriage. It needs a couple of square nuts. We've got one down here, right in there, one in the center, it goes right in the top up here, and then 2 in these slots up here. One there, and one there. We'll also go ahead and preload our zip ties. You want the zip ties to come from the bottom. These are the ones that hold it on the bearings. We'll feed it through, one like that. One over here on this side. And it is important to get those zip ties right because the heads of these can sometimes interfere with some of the moving parts. And then finally, in these 2 holes down here, we need an M3 nut pressed in. And usually you can use that long screw method. I use that later in the video. You can just put it on a longer screw and press it in the part. But for these, I actually like to pull it with a shorter screw from the back. So I just get them started with the long screw, and then I'll use an M3x10 and pull them on through. Let's screw it down until it's kind of tight. That way I know these are fully seated. I'll do the other one too. But when you attach these, that screw is still an M3x10 and it goes through that other part, the other extruder body, and it doesn't have all that many threads on that nut. So you want to make sure those nuts are pulled as close to the back of this part as possible. Just a little tip. Now we're ready to move to install this on the bearings on the printer. And while we're doing all this work, it's probably a great idea to go ahead and oil these bearings. Just put some machine oil on them. Sometimes I use that super lube. It works pretty well. But just make sure everything's moving freely. You don't have any bad bearings or anything like that. Then our new X carriage part, we'll just slide right on those top 2 bearings and the bottom one. And then we can snug up the zip ties. The head of the zip tie will go to the top of the part. And just like that, just make sure it's nice and snug and it's fit in that part. And this bottom one will be held on by a backing plate. You'll see that a little later. Then we can go ahead and thread our belt back on. In this design, they just go down in these teeth right here. You can just feed it in. I use an O-ring pick to push it down in there sometimes. The belt will run through the bottom of the printed part right here, loop around the idler, and then we'll put it back in that other groove. Now the belt will have to be retensioned and shortened quite a bit. So let's go ahead and take off the X motor, or at least loosen it up. We'll just loosen this top right screw, and then we'll back these other 2 out. It'll actually pivot on that screw. So it'll swing down. That'll give us enough to tension up the belt. Back to the X bracket. Make sure the belt is on the teeth on your motor and it's correctly on the idler. You don't want to misjudge this. You don't want it to be any longer than it needs to be. But we're just going to find a set of teeth where it's somewhat tight. We'll just put it in there like that for now. You can see there's a lot of slack in the belt. But now we need to judge from that X motor how much we need to tension that belt. Make sure you can pull the motor up to get those screws back in, but the belt isn't too tight. So I can pull it up and the belt is tight, but not too tight. So I'm going to go ahead and put those 2 screws back in. After all 3 of those screws have been tightened up and I'm okay with that, I'm going to test that belt tension one more time. And that feels pretty good. And you can see I do have it pressed down inside the part. I have some excess. You can just go ahead and clip that off. Double and triple check this configuration before you clip that belt. But we should be good here. And then we'll just make sure that it's down inside the part. Belt's back on. With any design change, it's always a good practice to make sure that belt lines up on the gears and the idler. You can see there's space in both sides. It might rub a little bit one side or the other, but you can adjust that gear left or right from this angle. Just take the grub screws out and pull it out if you need to, but that's probably as close to the center as it's ever going to be. You might want to check that. Check the bearings as you're taking this stuff apart, especially with a machine that's from 2017. It's got a lot of wear on it probably. There's also another trick you can do to make sure that belt is tight enough. You can grab the motor shaft here, it has a flat spot on it with a pair of pliers, and then try to move your X-axis. You shouldn't see any belt ripple at all. It's going to be really tight. So we should be good. Next up, we're going to assemble the idler door. Here are your Bondtech gears. One side has these roller bearings with a pin. They also give you an extra grub screw. Hang on to that. These are a lot shorter than the standard ones you see, so if you ever need one of these, it's really handy to have it. So we'll take the gear without the grub screw, and we'll put these roller bearings inside. Make sure you have both. They just slide in, and there's a couple of different styles of this door. I don't know which one exactly they're showing in the manual, but on this style, you just have one long pivot for this style extruder, and then this is where that idler screw goes, the one with the spring on it. But you'll want your Bondtech gear to set in just like this, and then we'll force the pin in. This can be pretty challenging sometimes, maybe even the hardest part of this build. Sometimes I'll use channel locks to put this on. Just be careful, it is a printed part. Once the pin's pressed in, just make sure it turns freely. Make sure that pin is pretty equal on both sides, pressed into the part like that, and you should be good. Now we'll get the extruder body ready to go. We got to load some nuts. We'll have 2 M3 hex nuts here that we can force in, and then some square nuts. One here at the top, and then one for the probe. So for these, I just like to put it on one of the longer screws and kind of wiggle it in place. There's one, and then we'll put one in on the other side. Those are in. We'll put a square nut up here. You don't want to forget any of these and then start assembling, because it's a real pain to go back and put these in. And then a square nut down here for the probe. Now we'll grab our filament sensor arm and our magnets. We want the short magnet. It will slide in here, just like that. And then we'll put that in our housing. It sets in here right like this. The magnet exposed on top. And that gets an M3 by 18 millimeter screw. It actually just threads into this plastic part. There are a lot of different length screws in this kit, but it's all for a good reason. You don't want them too long poking through the back or it won't mount. Get that one just snug. Make sure it moves in here freely. You want the magnet to be able to push it around. Then we'll take the long magnet and we'll slide it in this slot right here. Make sure this magnet repels this one. You want this lever to be pushed this way. That magnet can jump out of there real easy, but just make sure when you put this in, it's repelling the magnet. If it doesn't, flip it over. It should be just like that with the magnets forcing each other out. Then we'll take the filament sensor guide piece. This is kind of a roller the filament rolls on, so that filament sensor will work a little better. There is a ball that goes inside there. That is a 7 millimeter ball. And that sets in the housing, right like this, with that little bump facing out. Then we're going to reuse our extruder motor. We'll just take this 7 millimeter gear off. We'll clean this off a bit, but we'll get our printed part. It sets on here right like this. You want the hot end and the motor wire both going down. So it sets just like that. And this gets put on with 2 M3 by 10 millimeter screws. One there and one there. And now we can turn that motor shaft to make that flat side of the shaft face out. That's going to make it easier to put on your gear. Line up your grub screw with the flat part of that shaft and just slide it on. And you can just grab a piece of filament to line up that gear. Make sure it's following the correct filament path. You can just kind of lay the filament in here like this and then adjust it up and down and make sure the filament is right in the middle of those teeth. It's going to look something like that. The straighter the filament, the easier this is going to be. You can also use a really small Allen wrench if that helps. Then we'll get our extruder cover. It also gets a square nut here in the top. Then we'll go back to our main body and get our hot end lined up. You want to go ahead and put 2 M3 by 10mm screws in here because they're kind of hard to get lined up after the hot end goes in. Right there. And we have our existing hot end from our Mark II. It's going to have PTFE in it. We're going to pull that out and just replace it. The ones for this kit are 45mm long, and they do have a chamfered end on the one side, and that side goes down into the hot end. Just like that. Pull up on that retention ring, make sure it's locked in there. And then you'll set the hot end in here. You want the wires going out the side opposite the pin to probe, the side with the fan over here. So it'll set in like this. The wires on the side facing back. Some of those are looking kind of rough, but they should be okay. Then the extruder motor will slide on. Like so. And then your top cover will go on. Right there. And then you'll use 2 M3 by 40mm screws to put that cover on. They'll go all the way through the body. Remember, your extruder motor wires are going to be facing down. And before you tighten that last one up, make sure your heat block is in the correct orientation. We want to make sure that it's nice and square with the wires facing that way. There we go. The hot end and the motor are in place. Back to the printer, we're going to route our filament sensor wire. It's the red, white, and blue cable in the kit. You can buy these cables and the sensor and the ball and all the parts from alternate vendors if you wish. I'll leave a link in the description. But it routes up through this channel, and we want to leave some slack so you can plug that filament sensor in on top. So about like that. And the rest of it runs behind, underneath the belt. Then on our extruder body, we're going to leave a little bit of slack. Make sure our extruder motor wire is routed underneath this channel, because the fan will snug up in here. You'll have to do the wires for it too, so make sure it's pushed in. Your extruder motor wire will run underneath that belt, so we'll pull it through. Then the whole housing will go on. Mind the wires, you don't want to get anything pinched. Then these 2 10mm screws that we used, those can be threaded in. You'll have to have a ball-ended wrench, like the one that comes with the Prusa, to be able to get in there. And after you get both of those snugged up, one on each side, check the wire again. Make sure you're not pinching anything. You shouldn't be at this point, but just double check. Now we'll move to installing the filament sensor, this little IR sensor. Avoid touching this as much as possible. It's okay around the PCB and the pins, but you don't want to touch that reader at all. But it just sets in the top of the housing, right here. And then you can plug in your wires. Your red wire is 5 volts, and your blue wire is ground. And then we can attach it with this tiny little M2 by 8mm screw. It just threads into the plastic. Just screw it down enough where it's snug so it doesn't move around at all. The lever on that arm where we installed the magnets, that's actually what trips this sensor. So filament passes through here, that ball that we installed, it passes by that, and when the filament runs out, it trips that arm and it moves into that sensor's path. If you're going to print this out in different colors, make sure that arm is still black PETG. Other colors, it doesn't like to trigger it so well. So just keep that in mind. Now to pull this assembly together, we're going to use an M3 by 40mm screw from the back here, and we'll tighten that up and just make sure there's no gap in these 2 housings. There we go, it's nice and tight. Then we can install our new hot end fan. It's going to set on the extruder body just like this, but we're going to need a little bit of slack in the cable. So we're just going to push it over a bit, right like that. And then this cable will go inside that chamber and kind of squish that extruder motor cable up in there. The cable will run underneath the belt, just like the rest of the cables. And we'll just push the wire down in the channel and make sure it's tucked up in there so when we put the screws in for the fan, that it doesn't pinch any of those wires. And then we'll do M3 by 14mm screws here, here, and here. This one will be longer because it actually holds on the part fan duct. We've got 2 on. Once again, make sure you keep checking your wires. You don't want to get anything pinched. Then the last M3 by 14 down here. Now to the other side, we're going to go ahead and put on our idler door. It's worth one more check in here to make sure the filament is lined up in the center of that gear before we put it on. And you can see it in there. It looks good. The gear on the door will actually be aligned by this gear, so you shouldn't have to worry about that. It will fall into line when you put it on. So we can set our door on. We've already got our gear on from before. Set it in here right like this. From the back, you'll have an M3x40mm screw that runs through that hinge, and it gets screwed into the motor. You don't need to tighten this one up very tight because that door does have to move. And then from the other side, you'll have an M3x40 with that idler spring on it, and it'll run through the housing into this door. I forgot to mention that we should have pressed an M3 nut into this door, but you can do it after the fact. This is a pretty long screw. It'll run all the way through there. If you missed that nut like I did, make sure you tighten this screw up all the way until that nut gets pushed all the way into the part, and then we can go ahead and back it out. You can take the door back off and do it, but it's not a big deal. On this side, you want about 1 millimeter of screw sticking out, and then on the other side, that screw head is going to be pretty much flush with that housing. Start there, but if you see issues, you can adjust it later. This might be the most tight setting that you're going to see. You might have to back it out a bit depending on the filament. Next up, we're going to start on our part cooling fan. You have this plastic piece right here as a hanger. This is what allows it to lean out in the new configuration. You need to press an M3 nut in this side. Use the screw method from the back because that one has to be pulled all the way into the part for you to be able to use it. And then this side, we'll use an M3x10 to attach it on the housing in this hole right here. You will need some sort of ball-ended wrench because it's kind of at a weird angle. The wrench that comes with your Prusa kit will work great. And then it goes on just like this. Just make sure it's straight, and then your part fan will screw on here. Then we'll get our fan duct ready. We're going to use the one that Prusa printed for us because I'm guessing this is ABS, like I said before. There's a square nut that goes in this slot right here. And then it goes on the housing with an M3x20mm screw. So it slides on just like this, and then from the other side of the hot end fan, it goes through and then into that square nut. It goes on just like that. Again, that screw comes from this side all the way through into that square nut. And you can move it just a bit so we can line it up with our part fan. And then our part fan that was on our Mark II will mount just like this. And we have M3x20mm screws, one here at the top to go in that bracket. These don't need to be all that tight. You don't want to break the case on the fan. Make sure it lines up well with your duct down here. It should set right in there. And then on this side, I'll try to get you a shot of that. You have an M3 nut that goes on the printed part right here, right into that front cover of the extruder housing, and then another M3x20 to hold the fan onto that nut. There we go. Now check the orientation of your duct, make sure it's nice and flat, and it's not interfering with the nozzle. Now we can route our part fan wire. Again, it's going to go underneath the belt, just like the other wires. Give it just a little bit of slack, and then it goes through this channel. Then we can slide in our super pinda. We should have that square nut in there from before when we built that part. We're going to loop it over. We'll give it lots of slack. That wire again runs underneath the belt inside this channel, but we'll give it a loop there, and then an M3x10mm screw to snug it on. This is going to have to be calibrated. We'll do that after the assembly is complete. So just snug it for now. The pinda is on. Now we need to put our filament sensor cover on top. That's this one right here. It goes on with an M3x10mm screw. The screw goes towards the back of the printer. It sets on just like this. Make sure that this edge over here, the side with the adjustment screw for the idler, is nice and flush when you put it on. And our cover is on. Now we'll head to the wire management portion of the program. In the 2.5 kit, you do get a piece of nylon to help you with your wire management, this plastic right here. I have used 3mm nylon filament for this. It works just fine. But you're going to put it in this hole in the printed part down here below. It's underneath the belt. So you can use your pliers, just feed it inside here. It should be able to go in there a couple of millimeters, but that's going to keep your wire loom nice and straight while you're using it. Then we'll prep our back cover part. We do need to press one M3 nut right in here. I just used the long screw method here again, right there. Then we're going to get our back cover part and run the nylon and all the wires through this hole here. This is actually what holds this whole housing down. Pro tip, start with the largest plugs first. That would be your filament sensor. And then go to the pinda probe. All the wires that run underneath the belt will go in here. Your heater for your hot end and your thermistor cartridge will not. Then the fan wires can go in your extruder motor, and then your nylon. Then we can just thread it back towards the extruder housing and make sure all your wires, again, are in these channels as we move back, and everything should fit perfectly. Make sure your bottom bearing is aligned in your extruder printed parts. Now we need to build our wire management piece. That's this printed part right here. From this end, we're going to do an M3x40, and then we're going to put an M3 nut on that screw. You don't have to run it down very far. It can't go very far into that printed part, the back piece, or it'll interfere with that X carriage, that extruder housing. So we'll take a look at that. We'll just thread the screw into this piece just until it's flush with the nut on the other side. About 2 or 3 turns. It doesn't have to go down there very far. And then just snug the nut on this side up with your pliers, just to keep it from moving around. Here's what it looks like on this side. Again, just make it flush with that nut or it's going to interfere with a few things. You'll want that management piece put on just like this, and then we can slide the whole cover back. Again, watch all your wires, make sure everything fits. And then the whole thing goes on with 4 M3x10mm screws. We have 2 up here at the top. I suggest working from the top down. 1 in the center, then 1 down here at the bottom. Right there. We should be good. Then with all the wires that aren't attached to the heater block, your thermistor and your heater wires, we're going to go ahead and put our textile sleeve on. We'll get it started. Once you have it started, twist it a bit. You'll want the opening down here to be at the bottom because we're going to have to feed our Hotend wires in there. And then we'll go ahead and put some zip ties on that management piece. We want the head of the zip tie to be on top. And there should be 3 of them. 1 on the back, 1 in the middle. There's grooves on this printed part for the zip tie to go in. It really doesn't matter if they go left or right, just as long as they're facing the top. It shouldn't collide with anything. And then 1 out here on the end. Just like that, we'll go ahead and clip those ends off. Then we'll do the heater and the thermistor wires. We'll just bring those up. And we're going to use 2 more zip ties in between those 3. So 1 in between these 2, 1 in between these 2. The end of the zip tie will actually hang down a bit. So 1 right like that, and another 1 in between these 2. Right there. And now that we have our gang of zip ties on, all the rest of the wires are in the sleeve. We left that opening towards the bottom, so now we can feed in our Hotend and thermistor wires all the way down to the end. And the last thing we need to do is put our little piece that's going to contact the end stop switch that the Mark III won't have because it uses stitchless homing. This is the printed part we're going to use. You need an M3x10mm screw from this side, like that, and then the wedge-shaped piece goes towards the Hotend fan, right here. And it just threads in to that printed part. Just like that. And then you can test it, make sure it contacts that switch. You can hear it click. And we should be good. And our extruder rework is complete. Now we can move back to the bed and get everything installed there. Here's our 12-volt Mark 52. They have given us wires with the plug that goes onto the mini Rambo. I believe these are either 16 or 14 gauge, 16 probably. But they do have a couple of spade connectors on the end. From the top, we're going to use an M3x10mm screw, then a fender washer. Then that will go through the terminal. Make sure you have these on the right legs. VCC is here, ground is here. You don't want this wire twisted at all. Make sure it's as straight as it can be. You don't want them flip-flopped. They're going to go through here, through the contacts, just like that. And then the back, there'll be a nylock nut. So we'll get both of those started, and then we'll snug those down. And when you snug those up, make sure those have as direct and as much contact on those pads as possible, because this thing can draw quite a bit of current, especially at 12 volt. So make sure those are on there really well. And you'll notice on this bed, it is made for a Mark II. If it was on a Mark III, it would have just screw holes here where you would use standoffs. This has the standoffs attached, made for the Mark II bed. Just notice the difference if you're trying to source these parts yourself. Now with the wires on, we'll prep the printed part that covers this up. You're going to have one like this. The old school one had the nuts on top. You don't want that one. You want this one where the screws go down. And then you have this piece where you press in 2 M3 nuts. That'll go on the bottom. On this one, we're going to do an M3 by 10 millimeter screw. That sets through here just like this in this empty hole. And on the back side, we attach it with a nylock nut. It'll look just like this. Make sure your connectors are pushed in enough that they'll clear that housing. They need to go inside there. Then your thermistor can run right through here. You want just a little bit of slack on this side. You don't want it pulling, but not too much that it gets caught on something. Just a tiny amount. And then you can use this small sleeve to put on all your wires. And then once your sleeve is on, you will use this other part of the heated bed clip to set on top, and then you'll use some M3 by 10 millimeter screws to come from the top down into these nuts. And you want to make sure that you tighten these equally, and it's going to grip your sleeve down in this valley. Again, make sure you have just a little bit of your thermistor wire pulled out. You want just a little bit there so it's not pulling. Make sure the clip is down on both sides. You don't want a gap. You don't want to have one that's tighter than the other. It should be in there nice and tight so it doesn't move around. Then we'll just give our sleeve a little bit of a twist, and we're ready to put it back on the printer. Back to the printer. Again, this is a great time to do any maintenance that you need to do. If you need to oil the bearings or just clean the smooth rods off, do that. But we'll slide the carriage forward. We'll set our bed on here. And there's 4 standoffs on the corners of this bed, and they screw from underneath. And then we have the piece in the center with 2 standoffs where we attach the belt. So I'll get one started, then we'll flip it over and take a look. These are also M3 by 10 millimeter screws. They are button head, so they have a little bit more clearance underneath here. I got one started down here. We'll start this next one up here in the front. We'll do the one in the back. Mind your thermistor wire, it should be out of the way, but just make sure you know where it is. And our last one down here. The bed's been attached to the Y carriage. We'll go ahead and put our belt holder back, but also note the U-bolts on the bearings. The Mark II didn't have these. It was still zip ties. The Mark IIS upgraded to these. But if you have the kit, they do come with these U-bolts. They've even created some newer parts for the Mark IIIS to do this same job, but just note you can buy these U-bolts from other vendors if you need them. Our belt holder will attach with an M3 by 10 millimeter screw, one on each side. Then we'll put on our belt holder. Remember, it goes through the carriage and into the bed. There's some standoffs for this. 2 screws, M3 by 12 millimeter screws, one on each side. Now we're going to swap out the electronics case with the newer version. So we'll just remove this one. We have 2 hinges, 2 screws hold those on. They just go into the frame. Then this side of the case, you've got a slot right here that you can take off one of the screws that hold it on. It's right inside there. You can just back it out a bit and then slide the case off. You don't need to remove them, as well as the one on the bottom here. It's right underneath. Just back it out a bit. And then the whole case will just slide off. And just a heads up, there is a square nut inside the old door. You can take that out, use it for another project. And we're going to take our Rambo board out of our case. You can probably leave most of this plugged in. There are 4 screws. They're pretty close to the corners. There's one right here. They just have the M3 screws on the back of the case. There's one down in this corner. And then 2 in the top corners. One over here. And then one over here. And we can just lift that out. And we can just go ahead and slide it into our new case. Same thing. There'll be M3 nuts on the back. And these are M3 by 10 millimeter screws that go in the board through the case. One in each corner. The top of the board is the part that has the USB port. It goes in that hole right there. Now our board is back in our case, and we can go ahead and slide it back on our frame. Mind your X wire cable right here, because it gets put in this hole on the back of the case, but this will just slide onto those same 2 screws for the old case. And we can tighten those back up. And one of the biggest advantages to the new case are these wire holders here, this strain relief. And the bed comes in from the side, right here. And the retainer for the bed is a little smaller than the one for the hot end extruder wire. So the plastic parts are different. You'll notice this one for the extruder has a lot bigger valley than the one for the bed. So we'll put the bed down here on the bottom. This side gets the M3 nuts, and then the printed part side gets M3x10s. These go in pretty easy, just with a longer screw. And I just put about 10 millimeters of the wire wrap inside the case, and that gives you enough slack for your bed to move freely. But just test it, make sure that bed will move all the way back and all the way forward before you put it in there. And we're good there. So then we can put that plastic clip on. It has a flat side on it that goes towards the case, and then we can put M3x10s to attach it on there. Bed strain relief is on, and we're going to go ahead and move to the extruder part up here. Same thing, M3 nuts on this side. And there's plenty of slack on these wires. Again, I kind of use the same rule. About 10 millimeters of the sleeve inside the case. They're going to fit right through here. And remember, it's the larger of the two printed parts that goes up here on top. And these can actually be quite challenging to get on sometimes. That does have a pretty short screw, so I like to use the method of putting the nuts in and then pulling them through with the screw before I try to attach this. You want that nut to be as far forward as it can without breaking that part. You can get it on, but just be aware it might fight you just a bit. So now we need to go to the wiring. So the bed is the easiest one to put back. We'll go ahead and put the bed power back on. Goes right down here at the bottom. Make sure it's snapped on there nice and tight. And then the thermistor. Again, it has the green tag. It goes in that thermistor port over here. And now we need to talk about some of the adapters that this kit comes with. If you have the Pinda 2 probe, you're going to need one of these because it breaks out that thermistor wire. The Super Pinda shouldn't need it because it's just a 3-wire sensor. But this one will break that thermistor out to another pin. I don't need that one. But there's also this one. And this one gets us around using a 5-volt Noctua fan for our hot end on a 12-volt system. And you'll see more on that in just a moment. But these just clip on the wires that already exist. So we don't need to do anything with the Pinda wires. We should be good there. That is the blue, black, and brown. But the red, black, and yellow wires, the ones to the Noctua fan, will go in this side of this Y adapter. And that's going to let us break out the tacho and speed pin and the ground pin. And I actually just noticed, I take that back, the Super Pinda actually has a 4-pin plug because it's supposed to go on the Einzi board, I'm guessing, or the mini board, so we still will need this adapter. Or if you don't have one of these adapters, you don't want to make it, just go down to the 3-pin type. But we'll go ahead and plug it in here. That way I can show you where that white wire goes to anyway, if you have a Pinda 2. But the blue, black, and brown just go to the Z-min pin like they always did. That's this lower pin right in here. And then that white wire would go to the center thermistor pin, the one right next to the bed. So it goes right here. And as far as the hot end fan goes, the one with the 3 pins, the yellow and red, are going to plug in to our max in-stop pins up here. So they're going to grab 5 volt right up there at the top. This fan is only about 0.1 amp, so the draw on that pin should be just fine to power it. And then the ground will go down on our regular hot end pin so we can still control it. And that's right underneath that white thermistor wire we just plugged in. And I know that it's really hard to see inside there, but it goes right down in there. And the only other real change from our last configuration is that filament sensor wire. That's this one here, the red, blue, and white. The red goes to the outside of the board, but it goes on the pins underneath these LCD cable pins. There's 2 rows, I believe they call it AUX 3, and it goes on the second row. Fun fact, if you want to use an MMU2, it would go on that top row. Again, the red wire goes to the outside of the board, so it's going to go in there just like that. We'll plug in our hot-end thermistor. It's the one with the yellow and green right there. And then right below that is our part fan. It's the one with the red on it. And it's right there. It doesn't have a shroud on it. Make sure the red wire goes up, closer to the thermistor wire. That's your part fan. Last but not least, we can plug in our hot-end heater cartridge. Right next to the heat bed. Right down there. And that should be it as far as wiring goes. I know it is a mess. I highly suggest you get in here with some zip ties and try to corral some of this. If for nothing else, maybe a little bit better airflow inside here. I know this hurts a lot of you while watching this video, seeing this wire mess. We can go ahead and put a bottom hinge back down here below. Almost forgot to plug in the extruder motor. It goes back down in there. It's the bottom one of all the motors. Now we can put the hinge on. We can load a square nut on our door, right in here. This will hold for the latch. Put our door on our hinge. Once the door is on the bottom hinge, then we can put our top hinge back on. Just put it back on the door. Then we can screw it back to the frame. Then we can close it up with an M3 by 40mm screw from this side. It goes all the way through the case. And our 2.5 upgrade, all the hardware portion is complete. We will need some firmware. So let's go ahead and power it up. And I'm going to cable up to my computer, USB. Your USB cable just goes right over here in the USB port on the top of the board. Then we need to go out to the Prusa site and get our firmware. Go to Prusa 3D, go to Support, Drivers, Firmware, and Manuals. There should be a section for the 2.5. Right here, we have the 2.5S. We're going to download firmware 393. We'll go to Downloads, and we'll unzip. We'll extract all. And there's a lot of different firmware in here for every board and every machine. But we're going to go to Prusa Slicer. If you go to Configuration, you go to Flash Printer Firmware. It already knows there's a Mark II on COM6, so it should notice what printer you've plugged in. You can rescan if it doesn't. But then we're going to hit Browse. Back to Downloads, where we put the files. We'll open up that Prusa 3D folder. And there are 2 different kinds of mini Rambo boards. There's a 10A, the very first ones that came out, and a 13A. I have a 13. It does say it on the board. Most of the printers are going to have a 13. You'll probably know if you have a 10. And then you can pick which hex file language that you would like. They're all English, but then they have a secondary language. How about we keep English and Czech? And we'll hit Open. And we will hit Flash. The flash has succeeded. You should see a message on the LCD screen. Old settings found. It's going to save the default PID and E-step settings. And now you can see on the screen, Mark 2.5S. Now we still need to adjust our pin to probe, so I'm going to go ahead and turn it back off now that our firmware is up to date. I'm going to bring the Z, both sides down manually until the nozzle touches the bed. I'll probably put it in the front of the bed, right about here. You don't want to force it, you want it just setting on there. And this is without the steel sheet, by the way. With the nozzle on the bed, I'm going to grab a zip tie, throw it underneath my pin to probe, loosen up the mount, and push that pin to probe down until it sets on the zip tie. We're looking for about 1 millimeter away from the bed, or above the nozzle. When you're set down there, go ahead and tighten up your mount. And this is going to be a really good starting point for that probe adjustment. So after we're booted back up, there's really only one setting I want to check. That's on the Super Pinda. I want to make sure it's enabled. The rest of the settings should be fine. You shouldn't even have to update EEPROM or anything like that. It should be all the same. So let's go in real quick. Let's go to Settings, Hardware Setup. This is where you can set your nozzle size. You can put your steel sheets in so you can flip out to different ones. And then down here we have Super Pinda, and it's automatically default set to no. So I'm going to set that to yes because we do have that installed. Everything else should be good, and most of the settings are in this menu here. I set sound to silent. I don't need to hear it beep. High power mode is what I always use. Fan check is good. F auto load, that's so the filament sensor will be tripped and it will go ahead and bring the filament in automatically. Filament sensor is on, you need both of those. All the default settings for everything else should be just fine. But other than that, I'm just going to go ahead and run the wizard that would normally run on the printer's first boot. We'll just go ahead and reset, treat it as a brand new printer, just to make sure everything's working correctly. So if you go into calibration and then wizard, that will start it all over. So hit wizard. It's going to tell you that running this again is going to delete some settings. That's fine. And we'll go ahead and start it. It's going to tell you hello, which I always find great. And yes. Now it's going to do some self-tests. It's going to test the fans. You can barely hear that Hotends fan running, which is awesome. Now it's doing the part fan. Yes, it is spinning, so those are good. Now it's going to check the in-stops. X looks good. Y is good. And now we'll check Z. Now I do have my sheet on right now, but for the calibration, you really want to leave it off. You'll see that more in a moment. Now it's going to test the bed, make sure that it's heating up correctly. The bed's good. Now it's going to heat up the hot end, make sure it's good. And the hot end's good. Everything's correct. So that's a good sign that we got all the wiring done correctly. Now it's going to move to the XYZ calibration. So it's going to home, but it wants to move the Z axis all the way up so we can level it with the top of the frame. So we'll just turn the knob until we get all the way to the top. We'll let it get to the top, and I like to turn it a few more just to make sure it's even up there, and then hit the button. It's going to ask if the carriages are all the way up. We're going to tell it yes. It's going to make sure that the nozzle is clean, which ours should be good. Then it's going to ask if the steel sheet is on the heated bed. We want to remove it because that's the condition that it wants. So we'll go ahead and tell it no. Then it wants you to put a piece of paper on the bed in case something bad happens. You don't want that nozzle touching your PCB, but I'm pretty confident in the way we adjusted our pin to probe that it won't contact it because I've done this quite a few times. So I'm not going to put the paper on. I'm going to go ahead and let it do its thing. So we'll just hit the button. Now it's going to come down and check all 4 points on the bed, one on each corner. to make sure there's no skew in the printer, everything's assembled correctly, and it's all working. And this does take a while, so we'll just let it do its thing. Now, when that process is complete, it's checked all 4 spots on the bed. Now we put our steel sheet on. After the sheet is in place, we can go ahead and hit the button, and it's going to do a 9-point level. And if everything was successful, you'll get this message: the printer is perpendicular. So we're good to go. Go ahead and hit the button. Now it's going to want to do a first layer calibration. We don't have filament loaded, so we'll hit no. Then we can go to the preheat sequence. We'll just use PLA, and we'll wait for it to come up to temp. We're up to temp, so we will insert some filament. And hit the button. We'll make sure everything's feeding correctly. Looks like we're getting some filament out the nozzle, so we'll go ahead and tell it that the filament is correct. And now we're going to run the first layer calibration, where it's going to print a test pattern on the bed. Now we can adjust the first layer by bringing it down a bit. I know it's going to be higher, so we're going to go ahead and go in the negative. And we'll keep adjusting until that first layer sticks. So we're not quite close enough. I'm going to run it down just a little bit more. So we got all the way down to 850. It looks pretty good. I think that's a pretty good number for our first layer. We can always adjust it after the fact, but we should be in good shape. And it will automatically save these settings to the first smooth sheet. If you got a powder coated sheet, you can go into settings and hardware setup and try to save it in one of those slots. So everything is set up, ready to go. I think we should run a test print. And there we have it, our test benchy is complete. Not a bad benchy at all. So there it is, our Mark IIs to 2.5S upgrade is now complete. And I will say it again, this video is probably not for everyone, but I had to do this upgrade anyway, so why not make a video? And there might be some information in here that helps you source your own parts to upgrade your machine. And it might help on some of those clone machines out there that are a lot like the Mark II, and be even a bit of an upgrade. So hopefully you found this at least interesting. That's it for today, and I'll see you very soon on the next one.